Assalamu alaikum and welcome to Abdullah Sir Science class. In today's class, we'll be learning about the natural phenomenon, the amazing concept of light, that is formation of rainbow in the sky. So without wasting much of our time, let's get started. To the class, and in this class we were learning about the dispersion of light. So the magic of science, what we are talking about is this. See, all the phenomenon, the concept behind is the dispersion and the refraction. Let's learn it. So the topic for today to learn is dispersion of white light by a glass prism. So if we are good enough in understanding the dispersion concept of light in the glass prism, then we will be able to understand very well about the formation of rainbow. All right, so before going to the topic dispersion, let's have a look at the light and the electromagnetic spectrum. Right, for that I need to switch my window to this. Right, so have a look. This what you see is nothing but electromagnetic wave. The energy is represented in the form of electromagnetic waves. All the energies travels in the form of wave, and these waves will have certain characteristics like wavelength and speed and frequency. Let's have a look. So here if you see the gamma rays, when we are talking about gamma rays having the shorter wavelength. If you see, the gamma rays has the shorter wavelength, and the shorter wavelength of electromagnetic light, the shorter wavelength of light has the greatest frequency. If you see, the frequency is 10 to the power of 24 hertz, and when you're talking about the wavelength, it's just 10 to the power of minus 5 nanometer. It's very small value. So wavelength is nothing but the length of one wave. It is the shortest one. So what we understood with this the scale, we understood with the scale that all the electromagnetic waves are named differently because of their characteristics, because of the different wavelength, frequency and their speed. Let's have a look. The gamma rays has so shorter wavelength but the higher frequencies. The X rays has medium wavelength, but the frequency is decreasing at the same time, and as you see, the frequencies are decreasing from here and the wavelength is increasing as we go from left to right. You see, the values are changing. You see, it's 1 nanometer to 10 power 3 nanometer. That means the wavelength increases. You see, the waves, the length of the waves is getting increased and the frequency is getting decreased. So this whole set of energies is called as electromagnetic spectrum. What do you call it? Electromagnetic spectrum. The spectrum means the range of electromagnetic waves, the values which starts from 10 power minus 5 nanometer to 10 power 3 nanometers of the wavelength, right? So you understood about the electromagnetic waves, all the energies represented in the form of electromagnetic waves because they travel as waves, and so they have the characteristics of wavelength and frequency, right? So this portion of section of electromagnetic spectrum, which is visible as some colors, this itself is what you call as light. We call this spectrum, we call this portion of electromagnetic wave as light. Why do you call it as light? Because this is the colors, this is the thing which is visible to us. So we generally call it as a visible light or visible spectrum, right? What do you call it? Visible light or visible spectrum. So this visible light or visible spectrum only and only has the shortest range of electromagnetic waves, wavelength to 700 nanometers of wavelength, 400 nanometers of wavelength to 700 nanometers of wavelength. All right, so 700. So this means the value, you see the difference is very small. That means the electromagnetic waves had a very shorter portion in which we as human beings are able to see the lights. Our eyes are only sensitive to the electromagnetic waves, which is between 400 nanometers of wavelength to 700 nanometers of wavelength, very shortest wavelength. Okay, this shortest wavelength is visible to us as a colors of light, so we call it even as a visible spectrum. What do you call it? A visible spectrum. So see, the colors are different. Why do you think this light has a different colors? Because they have different wavelength, different characteristics, right? Like wavelength, frequency and speed. So why do you call banana as banana? Because it is banana, it's different, right, than apple. Right, apple having different characteristics. It's solid, it's semi-solid like thing, right? It's soft, it's hard. So there, the color difference is there. So we call violet as violet because it has 400 nanometers of wavelength, and we call red as red because it has 700 nanometers of wavelengths, right? So if suppose you're choosing any light which is having a wavelength of 700 nanometer, that means surely it is red, right? Let's come back to the topic. So we understood about electromagnetic spectrum very well. What do you understood with this? We understood a point that, sir, this colors of visible spectrum having different characteristics. Okay, then how is it related to our topic? Our topic can't be learned, can't be having a clear picture unless we go through this. So we had just gone through this. All right, so let's have a look at the color of the light coming from the sun. We're talking about the photo of sun taken by a rover on Mars, right? So from the Mars, the rover sees the sun and captures a photograph. You see the color of the sun, how small the color, how small the sun is. This sun appears to be white or not. It is actually white, and this white color of light, that is a major portion of color of light what coming up from the sun is white. So if we have a look at the experiments, and if we go through this, we got to know that this white light is actually constitute of 7 different colors, that is violet, indigo, blue, green, yellow, orange, red, that is VGR, right? So as what we have just learned in the electromagnetic spectrum, that is this. Here we have just now learned that we have the colors, that major 7 colors are violet, indigo, blue, green, yellow, orange and red. So electromagnetic spectrum, in that the visible spectrum is violet, indigo, blue, green, yellow, orange, red, which is visible to us, the human eye is sensitive to, right? And the color of the sun is white in color, but the white light is constitute of 7 major colors, which is violet, indigo, blue, green, yellow, orange, red. And this is the reason that when these colors are going going all together, you see it as white in color, and when they get separated, the colors are visible to us. All right, that's it for today's class. We'll be ending our topic. That the concept is not over yet. Wait for the part